Okay guys, I'm going to make a video here to help you guys to start off with radians on this one, and this was 10.2 on radians. So to start off here, I just want to talk a little bit about something that was in AGS2 that you may or may not have gotten to last year, and that is the subject of arc length. So if I have a circle, you can just listen for this part, you don't have to take notes. If I were to have a circle and I were to give you its diameter of like 10, for example, that would mean that it would have a radius of 5. Let's just start with the radius of 5, actually, that'll be easier for my example. Okay, and if we wanted to get the circumference of the circle, we know that the formula is 2 pi r, so it would be 2 times pi times r, and the circumference would be 10 pi. Now, this is that part you probably know. This part maybe you didn't know. There's something called a length of kind of an arc, okay, or arc length. So what that is that's just like a portion of the circumference. Okay, so if I wanted to know how far it was, not of the whole circle, not the whole 10 pi, but just from here to here along this outer edge in blue, that's the part that we need before we start talking more about radians. So you have to know this angle in here. So let's say that we knew that this angle was 30 degrees. Okay? So what's going on here is that this 2 pi, and this will be helpful with radians, that 2 pi is representative of 360 degrees. It's representative of the whole entire circle. But we don't want the whole circumference on this one. We just want that little blue part. So instead of taking all 360 degrees of the circle, we're just going to take this is kind of like the percent or the part of the circle that we would need, right? And then from that, we're going to go times 2, and then pi times the radius, okay? And then that right there is going to tell us that just that one small part there would be what? Well, if I multiply all of my numerators, I would then get, let's see, it's 60 pi times 5 is 300 pi over 360. Okay, so that would represent, and you could get it as decimal or you could leave it in terms of pi, but that would give you just the length of that blue segment. Okay, now if I wanted to kind of do a proof of this, just to show you guys that it does in fact work, I would think about how many of these 30-degree angles would go around the circle, like how many pieces of that size pi would go around, and we know that 12 times 30 is 360, right? So it'd be 12 pieces of those pi. So when I multiply this by 12, I better get 10 pi, okay? So what would I have? I would have 3600 pi over 360, and 3600 pi divided by 360 is in fact 10 pi. So hopefully that made a little bit of sense to you, and that's what's called arc length. You're just taking the portion of the piece of pi that you needed to know. So if this angle was really small, like if that was 10 degrees, here you would have 10 over 360, and then you would do it just like you would normally do circumference. Okay, I want to talk a little bit about radians here, and then I'll even do a couple of problems on the checkup from 10.2 with you to kind of get you going. So this is a file, you guys know that I've purchased this before, it's very straightforward. I don't know if I can post this to Canvas to not, I'll try. After the video, I'll try to post both the problems here and the answer key to the whole thing. And basically this, what you're looking at here, it's a gigantic file, and it covers most everything we're doing for the rest of the year, and it'll be very helpful to you, and I'll try to get it to you if I can. Okay, so let's talk just about a few things here, and this will help you with 10.2. Okay, an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. Okay, So here's our ray on the positive x-axis. The ray on the x-axis is called the initial side. Okay, and it's on the positive part of the x-axis. The other ray is called the terminal side. So you may, if I was successful in uploading this to Canvas, you may have already, downloaded this to your device and maybe you're writing on it right now. If not, you might want to pause the video and go ahead and do that and follow along, or you could just listen. Counterclockwise rotations result in a positive angle measure. Okay, so see how this is counterclockwise? So this would be like positive 120 degrees, okay? If the angle was like this, and that was the terminal side, and this was like, that's like negative 50 because I'm going in a clockwise direction. One full revolution is 360 degrees. Okay, very good. It starts off here just sketching an angle with it in standard form. So 75 would be kind of here. Now negative 160. Okay. So negative is going in this direction. Okay, here's negative 90, right down to there. And this would be negative 180 all the way over to there. So negative 160, that would be the terminal side there. And this clockwise direction would be negative 160. 430, okay, well, I know that that's positive, so it must be going in a counterclockwise direction, so I'll go all the way around. That would be 360, okay, and then 360 plus 90 is what? 360 plus 90 is 450. That's a little too much. So if I were to go here, I would see that a 450 degree angle is the same as 90 degrees. But this is 430. So that would be a 430 degree angle. And you can see that it is the same. Well, it is the same as what? It was 360 plus what to get to 430? That would be 70 degrees. So 70 and 430 are the same thing. Okay, now we're getting into the tough stuff. Okay, here we go with radians. All right, a radian is a unit of angle measure based on arc length. We talked about arc length earlier. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Whew. Recall that the circumference of a circle is 2 pi. That was a little wordy, but all it's saying is that the radius, this distance, is equal to the arc length. So in this case, those two are the same. And if you have trouble picking this up, I really encourage you to watch those Khan Academy videos that I sent out on radians, or you could just do a Google search, the word radian and the word Khan, and watch the first video that comes up. It is very, very helpful, okay? So on that previous slide, I talked about how 360 degrees was the whole circle, okay? It's 2 pi, like from 2 pi r, the circumference, right? The whole circle is 2 pi. Okay, and then, so if 360 is 2 pi, 180 is half of 360, so 180 just must then be pi, okay? And then it gives you straight up the formulas of how to convert from degrees, which we're used to radians, and from radians into degrees. So radians are just kind of the portion of the circle, again, that you're dealing with. All right, so we're talking about a 30-degree angle, okay? So let's pretend right now that this was 30 degrees. That looks like it might be a little bigger than 30 degrees. We got our initial side here and our terminal side here, okay? It's positive because it's moving up in a counterclockwise direction. Now, we want to know what that is in radians. In other words, we want to know what portion of the circle that is. There's a little more to it, but that's a big part of what radians are actually about. So let's use the formula and then make sense of our answer. So I see here degrees is equal to radians times 180 over pi. Let's just do it and see what we get. So I would have, oh no, I'm sorry, I want this one. I want this one, okay? because it says convert to radians. We have degrees, and this is the math we need to do. So we're going to go 330 times pi over 180. And that's going to give us 30 pi over 180. And then I would reduce my fraction, 30 over 180. I can divide both of those numbers by 30. And that would give me 1/6. And then the pi is up on top. Or I could just think of this as, just pi over 6. Now I want to take a moment and I want to make sense of that answer. Now we know that the whole big circle is 2 pi. We know that 360 is 2 pi, right? So just like we did last time in my previous example, how many of these 30-degree angles would go around the circle? How many pieces of pi would it take us to finally get to 360? Okay, well, just like before, it would take 12 of them, because 12 times 30 would give us the whole circle of 360. So I'm going to ignore this for a minute. When I take pi over 6, which is in radians, right? And we know it's equal to 30 degrees. When I multiply that by 12, what should I get? I should get 2 pi. I should get the entire circle. And you can see if I take this and I multiply it by 12, I get 12 pi over 6. And 12 divided by 6 is 2. And I get 2 pi. Okay? And that's really all there is to it. And then you're going to go from convert each measure to degrees. And then it gives you the formula for that too. So I'm going to erase all of this. So if you want to write it down, you can pause it. But we need to get rid of this so it's not confusing. So all this is going to go away. Okay? All right. So think about 4 pi over 3. And first of all, I just want to kind of make sense of it. Okay? That's 360. Okay? So 4 pi over 3 is smaller than 2 pi. So I know that my answer, when I'm trying to make sense of it, it's going to be a number that's smaller than 360, okay? What about 180? This would be 180, right? Because pi is 180, pi is half the circle. So I know it's also going to be bigger than 180, because 4/3 is bigger than 1. So my answer is going to probably be a little bit bigger than 180, but less than 360. So let's do the math. So it says that, let's see, degrees, radians times 180 over pi. Okay, so here's our radians. 4 pi over 3 times 180 over pi. And that's going to equal 720 pi over 3 pi. And when I divide those, 720 divided by 3 is 240 degrees. And the pi's cancel out, okay? So remember, here's the way I remember these formulas. You're either multiplying by pi over 180, or you're multiplying by 180 over pi. Sometimes it's hard for kids to remember which one goes with which, okay? I know that this one, like when I do these, when I'm going radians to degrees, I know that degrees are written without pi. So I know that pi has to be in the denominator, so the last step will just leave me with degrees. So that's how I remember that degrees is going to be 180 over pi, and radians is pi over 180, if that makes any sense at all. Or you can just memorize the things that are written up there, okay? So that is just a little bit about radians, and I think I'm going to make a separate video here. I'm actually going to get into a little bit of the checkup problems you had on 10-2. But that is how you do most of it.